Hey,
Is that it?
welcome.
We're off.
Yeah, yeah, we are. We have nothing scripted.
We don't even know what we're going to be talking about.
Well, I have some idea what we're going to be talking about. We're going to be, first we're going to be testing out this coffee. So welcome to the Joeveo podcast. You can probably tell this is our first episode because he's really awkward and I'm still trying to figure out how I'm going to run this whole thing. Yeah, welcome. We're going to be testing out a coffee, which is Panamonium, right?
It's Panamanian from Panama.
Okay.
And it's you might call it single origin, but the single origin is one country. So at least we know all the beans came from one country.
Okay, I'm going to go ahead and say this. I know very little about coffee. What would you consider Joeveo? What kind of company would this be, or business?
Well, coffee related.
Coffee
We don't make
related.
the coffee, but we hold it for you. Keep it at the right temperature.
Right. Hold it at the right temperature. But we're going to be testing out a coffee, hopefully with each podcast episode that releases month to month. We're hoping something along those lines. Definitely no promises whatsoever because, travels and just having to commit to a particular podcast. I'm already recording another podcast. I just realized I still have the tags on here from highly professional. Well, whatever. Yeah, so hopefully like maybe once a month, once every 2 months or so, we'll record a podcast where we try out a coffee. And certainly, don't take our opinion for it. We're just complete amateurs. He probably knows more about coffee than I do, but I've been trying out different types of coffees. And so we'll try out some different coffees, and then we're just going to literally talk about just about anything. If you have any ideas on or topics you think would be interesting to talk about or get our opinion on, then, I've always actually, let me quick start by this with saying this. It's always been weird to me for people, especially on like the YouTube community, for them to like vlog their life, because it seems strange and kind of arrogant in a way to think that, why would anyone care about another person's opinion when they're not, famous? And that's a whole nother discussion. Like, to me, I don't care if a person is famous. Like, that doesn't mean anything to me. But unless they got famous for doing something particularly amazing, then sure, then I care because they did something amazing. But, like an actor, to me, that doesn't mean much. But like people on YouTube, they sometimes are like, hey, ask me questions. Like, all right, I don't even care about your answers, so I don't know why I'm asking you questions. So it does seem a little strange for me to say, hey, if you've got particular topics that you'd like us to talk about, then send them our way so we can talk about them because you might not even care about our answers either. But anyway,
It'll definitely help us out though, because I didn't even remember that we were going to be talking about coffee. That gives you an idea of the level of preparedness we're offering here.
but he did have the coffee, so who needs to be prepared, right? Okay, so let's give it a shot. Where's yours?
Mine's over here.
Okay, so mine is black. I tend to like my coffees black. This is the majestic original, well, not original, it's, I guess, non-prototype original Joeveo mug.
It's one of the first, actually.
One of the very first. Ba-bam, ba-boom. I feel like I'm on QVC. So this is black coffee, or Panamonia.
Panama. It's from Panama.
I get that. Like, what's the name?
Panamanian.
Panamanian.
That's all.
Like Tasmanian.
That's all I have to say about it. Is it's from Panama.
Okay.
Panamanian.
Okay, so let's give it a shot.
I'm drinking mine iced, by the way. And since I forgot that we were supposed to be talking about coffee, I also put vanilla and simple syrup in mine. So I have an iced vanilla Panamanian coffee, and it tastes very good. but it tastes mostly like sugar and vanilla.
Yeah. Well, I will say I like it, but I have tried. So, I mean, admittedly, I really don't know that much about coffee. I really don't. But like, if you were to talk to like a coffee roaster, or I don't even know what a professional coffee spokesman would be. Like, you've got sommelier when it comes to wine, right? Brewmaster, something like that when it comes to beer.
Barista for coffee.
Okay, barista.
A coffee expert.
I mean, I always associate Starbucks barista, so I don't really consider them experts. But I mean, if that's the like official term, then Starbucks has really butchered the barista term. But I will say, like, I do like it. I've tried other coffees recently. I can't. I probably it really shows that I don't know. I should have prepared for this because I completely forgot the name of that particular coffee that I've been drinking recently. I've been trying like different flavored coffees that are like black, but they have flavor to them, like I don't know, like cinnamon and there's another one, caramel, if you pronounce it that way. And that, I mean, that's been really good. That's been kind of my go-to recently. Aside from that, I've tried the good old Dunkin' Donuts coffee. So,
Donut shop blend.
yeah, you could tell my expertise is quite low. But yeah, it's not bad. I remember I tried one. Again, I don't. The name blanks for me, but it was so bitter that I couldn't even drink it. I really just hated it. Hated everything about it. It was like some tropical coffee that I had. It was pretty atrocious though. I got it from good old Walmart. So their coffee selection. They do have it. I mean, I don't know. I feel like a barista is going to watch this if they ever do, or listen to this and think like, wow, he went to Walmart for his coffee. He doesn't know anything. That's the point. That's exactly right.
Yeah.
But I went to Walmart and they've got a decent selection of different coffees. I don't know. Where do you get your coffee?
Well, they do, but I find that all grocery store coffees taste the same. So, I mean, this particular one is from Lidl, and like I said, it's at least from a single country. But I don't find that it tastes noticeably better than Folgers.
Folgers. There's also what, Countryside or something like that. I think that's what my mom drinks. So yeah, not that extremely. I mean, it's an easy drink. If you drink black coffee, Panamania,
Panama.
Pan,
Panam.
even he's
Panamanian.
getting confused.
Panamanian coffee.
Right? Tasmanian. Wow. Okay. Panamanian is definitely smooth. It's easy to drink. Definitely is black coffee. I don't usually put anything in my coffee, so that's essentially, if you want some sort of really baseline rookie understanding of coffee in terms of taste, then you could take my take on it. But
which tastes like every other coffee.
well, no, I think it tastes a little bit better than some of the other ones that I've had. There's particular ones that are more flavored that I like, that recently I've gotten into. I guess maybe it could just be a kick for me. But yeah, I mean, it's good, but it's not blowing my socks off. We had one that you from here in North Carolina, Wake Forest, that I had, and I was just like, it was really good.
Yeah, we're fortunate to have a very good coffee roastery here in Wake Forest. It's called Black and White Coffee Roasters, and they really know their stuff, and you can get any kind of grocery store coffee you want, and to me it all tastes the same, but every single one of their coffees tastes different to me, and it's always a mind-blowing experience.
Yeah, I had it twice. One time at the prepared by the barista, and the other time prepared by you. And yeah, it was good. It was great. I mean, it wasn't just good; it was really great. I usually get like Americanos and things of that nature, just because again, it's kind of a flat. It's just whatever the coffee's going to provide you. That's what the coffee's going to provide you. I'm not adding anything to it, and yeah, it was really really good. So maybe we'll try that sometime again, and I can rant and rave about that as well.
We should, yeah, since it's right here in Wake Forest.
Yeah, exactly. So I did have a few topics I wanted to talk about that I had written down. He didn't come prepared whatsoever.
I did ask.
Uh, yeah, okay. So I went to, so July 4th was like last week. Yes, last week, last Thursday. And I was having this discussion with this person. I went to a rooftop, like, get together where we could see the fireworks and everything across Baltimore. It was really nice. You could actually see fireworks on really all, like, from every side of Baltimore. It was really cool. But the main fireworks were like right down the center near the harbor, and that was really nice. But beforehand, I was having this discussion with another student that I don't know that well, but it was like the first time that I actually got an opportunity to talk with him and kind of get to know him a little bit. So we talked about music and we talked about a few different things, and he's clearly a science nerd as well. So two biologists, me and him, were talking about teleportation. So I wanted to get your input on this, and I think we've talked about this like really briefly, and I've never fully understood, like, because I have just about no physics background whatsoever, but it was teleportation of a particle. So I was listening to the Joe Rogan Experience. I've told you about that podcast before, and he had someone on there. Again, my memory seems to be failing me, but I don't know who it was. But it was a physicist, and he was talking about how teleportation had occurred before, but it was a particle that they had teleported. First off, what? Like, what's your first reaction when you hear somebody say teleportation has been successfully done on anything, like even a particle?
Well, it seems to me I recall reading a headline on that, but that's so far from my field of interest in physics that I didn't even read the article, so I'm not sure I can add much to that discussion.
But, I mean, presumably the idea of teleportation is, it's not traveling, right? You're not moving from point A to point B.
I mean, if you look at the meaning of the word, that's what it means. Yeah, you're moving something from one point to another.
But then that would imply that you're moving, I mean, beyond the speed of light, right?
If it's instantaneous, yeah.
Yeah, but that's what throws me off. Like, instantaneous, like how, like, there has to be some measurable amount of time between an object or whatever that is being in one position. Let's say you've got a jar and you put a particle in it, and then, which seems really weird, and then you've got another jar and you've got nothing in it. Particle moves from one jar to the other and the lids are closed. Like, that's what I've always thought of when it comes to teleportation. Like, beam me up, Scotty, you know,
right.
just like, you know, and just get beamed up into the Enterprise.
And if you recall, that takes a while and doesn't always work, especially if the neutron generators aren't functioning at top efficiency.
Right. So there's an actual movement process of moving an object from one place to another. You're not literally just like disappearing and reappearing somewhere else.
I'd have to read the article, but it seems to me that's what it means, yeah.
Okay, so then, but then you know a little bit about Einstein, and what's the equation? E equals mc squared for the speed of light. And the thought process was that light is the fastest we could ever go.
Yeah, right. But when you get into quantum physics, weird things happen. I mean, you're talking about teleportation, which I assume means that they're moving some mass from one point to another. But there's also the concept of transmission of information from one point to another, and that apparently has also been shown to be able to be carried out instantaneously. So somehow you can have a particle in one position that's coupled to a particle in another position, and when you change some property of the first particle, the state of the second particle changes instantaneously. So you're transmitting information at faster than the speed of light.
Define quantum.
Quantum is the field of physics where you're looking at not continuous changes in state of not looking at continuous changes, but changes that happen in steps. So in quanta, in quanta, in discrete quantities. So there's, you may recall from your physics exposure that light can have the characteristics of a wave or of a particle, and when the light is behaving like a particle, it's a kind of quantum behavior. So you can't have less than one particle of light. So you can have one particle of light or two particles of light, photons, but you can't have 1.5
Okay.
photons. It's discrete steps.
Okay. Is that just something we've defined, or is that something we've actually seen? Like, as in, like, math is something that I have strong feelings about math, but I always have negative feelings, just to be clear. But I mean, a lot of like mathematical principles are just things that we've thought about and then we've just kind of implemented, and it's just described the world that we live in. And it's done so excellently, beyond my intellectual capabilities or my willpower, I suppose I should say. But when you're talking about like a particle and it's moving in a stepwise fashion, is that something that we've actually seen? Like, cool biologists would think you've seen? Or is that like just an understanding, something that we've defined, and that's how we offer structure to how we understand the world? Because physics is essentially understanding the world, right?
Right. Well, it's both, actually. It's a model for understanding, but also we've experienced quantum phenomena all the time. I mean, there are many ways that it can be demonstrated fairly simply. In fact, I think the experiment that is used as an example to show quantum behavior is that of Rutherford, who directed a beam of X-rays, I believe, at a thin gold foil, and noted that most of the beam of X-rays passed directly through the gold foil, but once in a while you'd have a bit of the beam that would be deflected off the general path, and those were photons of, well, X-ray photons that were deflected by coming so close to the nucleus of the gold atoms. And that's an experiment that was done, I don't know, 150 years ago.
Okay. I mean, like, I understand it conceptually, right? That makes some sense, even with my extremely limited physics knowledge. That you're you're getting close to this nucleus, which is made up of, is that the neutrons?
Protons and neutrons, yeah.
Protons and neutrons. All right. All right. But it gets close to that, and then it gets somehow deflected because of the energy that's, or what?
Well, it can just like bang into the
Okay.
nucleus. And I mean, it's not like a auto collision. It's there are these forces between the photon and the protons and neutrons that that act on the photon, which cause it to change its path. And in pre-quantum physics, you would expect this beam. It's a beam of X-rays, but it's X-ray is just a very short wavelength of what we call light, electromagnetic radiation. You'd expect it to just go straight. I mean, like light does. Straight light goes straight, and you wouldn't expect it to be bouncing off of things in that manner.
Okay, so Rutherford saw this, observed it in some fashion 150 years ago.
Yeah, don't ask me about the dates, and it seems to me that this was one of the first demonstrations, or maybe the first demonstration of the quantum nature of light.
It's really hard for me to wrap my head around that, just because, like, if we understand particles as things, there are things still, because they can run into like a nucleus, right? They can run into the neutrons and the protons of something else. So they must have some sort of physical structure, or they are the most basic physical structure. Isn't there something about corks and screws? Something along those lines.
The protons and the neutrons?
Yeah, sure.
Yeah,
like,
if you take those apart, there's a whole stew of subatomic particles that have been slowly peeled away from their, binding forces that make them into a proton or a neutron.
So do you think that the probability is high that we're just going to keep digging? We're just going to keep going, and we're going to find out these quarks also have sub-Corkian properties?
I think the current belief is that they've got things pretty much mapped out. I don't know if they've observed all of the particles that have been predicted or required for the models that they're using, but they're pretty close. And I have never done any research or reading on this aspect of physics, so I couldn't tell you if there's any prospect of them, dividing a quark. I don't think so, but and then too, like you said, these are all just models that we use to understand how nature works, and of course there's always the intellectual curiosity of, is a quark indivisible? But if we've gotten down to a point where we pretty much understand everything, maybe no, I guess scientists will always want to take something apart if it can be taken apart. So yeah, if there is a subquark, I'm sure they'll be working on it at some point. Maybe they already are.
Yeah. So, but then the assumption is that all of this is theory because it hasn't been disproven, or more so that it fits all of what we've seen. Do you think that we're observing these things and then making them fit some sort of predetermined theory, or are we adapting the theory to actually incorporate some of the things that we're discovering?
I'd say that a little bit of both happens, with the object of finding a model for everything that doesn't leave any observed phenomena out.
Do you know by any chance, I know you haven't actually delved into this, but like, do you know if, like, how they're able to determine subatomic particles?
That's where these atom smashers come in, like the CERN observatory in France and Switzerland. And I guess that's the big one. And they just fire some particles that they can get a handle on together and look at how they explode when they hit each other. And they, from the models that they have, they can predict how, for example, a quark spinning out of that mess would behave. And if they see that behavior, they say, hey, that was a quark, and that's exactly what we predicted.
Are physicists magicians?
I mean, it's kind of like, I don't know, auto mechanics. It's like just taking things apart and seeing what's inside there, just at a very small scale. And they have to be pretty clever to come up with these experiments that prove or disprove their theories.
Yeah, but with like an auto mechanic, I can literally take out the pieces and hold them in my hand and feel the tactile nature
Right,
and actually visualize
that's what
it.
makes it a lot easier.
Yeah, right. Well, sure, it makes it easier, but like with you're saying like smashing these things together, and like in my mental image is just like two physicists like quote unquote smashing things together, but in reality it's like air. There's like nothingness because it's so small that they can't even identify. Like, as far as I know, I don't know anything about that kind of technology.
I know, it's pretty crazy. And then you get to using a technique like this, and it becomes like old hat, like this particle accelerator is like using a pliers. It's just, oh yeah, we use that all the time. It's just becomes part of your toolbox of things that you can use to do investigations with. I guess it's the same as like the tools you use, these high-powered microscopes. I mean, who would have thought that you could use electrons, for example, for imaging? How does that work?
I don't know. I don't know. But I can tell you, I've actually visually seen cells.
Yeah.
Like, I mean, they get dense enough on a plate that you can, like, without a microscope, just look at them. You see them. So.
Also, you don't need that $1 million microscope after all.
No, I
just
still
cut
need
that
it.
out of your budget.
Do we have cells? Yep. Just move it around a little bit, shine it in the light.
Let me put my glasses on.
And that's how the $1 million microscope became obsolete. Glasses. I mean, yeah, no doubt. Like, I think pretty much anybody could have, and I'm not saying it's like a criticism necessarily, but it's just so hard to wrap your head around it, because physics, people seem to be so right about essentially everything. It seems like, and clearly that's science, right? Like, you observe a phenomenon and then you try and fit it into a model, and then eventually that model becomes so good that because you've made billions of observations, and it's not just you, it's like an entire population of people have made the exact same observations over and over and over and over again.
Right, and all the results fit the model, so you think,
Right.
Okay, this one we got nailed down, let's move on to the next one.
Right, exactly. So, like, I get that aspect of physics, but I mean, beyond that, like when you're talking about smashing particles together and things of that nature, like, to me that's such a foreign concept. And I get that other people would feel that way about like what I do, with cells. Like, how do you know they're there, things of that nature. And like, it is true that you can actually see them, so I'd be happy to show it to you one day. But beyond that, like,
but you can't see all the subcellular mechanisms that people have posited and then proven somehow, or done research that supports that model to the point where everybody believes that, yes, this is how this molecule gets transported from outside this membrane to inside this membrane. Maybe you can't see that on a microscope, but like in the particle accelerator, you have this model and you test it, and yeah, that works, so we'll go with that.
Well, what's crazy is you can, right? Like now you can, in terms of like being able to see things on a microscope. It's honestly getting like incredibly scary how good some of these microscopes are getting. It's like it's not a field that I'm necessarily interested in, but if you talk to like a structural biologist, when they talk about a protein structure, I mean, you're talking about a subcellular, suborganelle protein. So, I mean, your cells are a certain size, and then your organelles have to obviously fit within your cells. And then within those organelles, those are all made up of a particular amount of proteins, right? And other structures as well. But to pick out just one protein, which is made up of, I mean, we're starting to get to like almost the atomic level at that. We're definitely going to the molecular level, right?
So you can see individual protein molecules.
Yes. Yeah.
But isn't it just like a mass of lumps that are like the fields that we call atoms?
Yeah. So they can get. I think it's measured by angstroms, something like that. So the lower the angstrom, the better. Now they're getting to like 1 angstrom, something like that. Like, which is, and they were talking about it in my class. They used to go to these massive facilities, and I forgot what it's definitely a physics principle, an engineering principle as well. I can't remember. Fourier. So they do a reverse Fourier, something like that. Some like where they're able to essentially look.
They're using X-ray diffraction patterns to determine the structure of the proteins.
Right.
So they get a Fourier, they get a pattern, and they do an inverse transform to work back to the molecular structure.
Yes. Yeah. So I mean, that's as basic as I know it. Like I don't know any more details than that. I think that's through like nuclear magnetic resonance, something like that. Like something, just like some crazy stuff. That's all I know. Crazy stuff. Like, that's why I'm not a structural biologist. It's incredibly boring too. Don't get into it. But it like the fascinating part is like they used to like, some people go, there's 1 or 2 places, like facilities, kind of like what you're talking about, these facilities where it's like this massive ring. It looks like a little bit like the Pentagon, but it's a ring. And I don't know what happens in there. They explained it to us. It was just like a
for
lot.
The NMR technique?
Yes.
Mm-hmm.
And I'm not sure if it's NMR. It could be something else. I'm not going to think about it right now. But like they go to these facilities, and one of them, I think both of them actually, one of them is controlled by like UCLA or like UC Davis or something like that in California. The other one is on the East Coast, and that one's held by like the NIH or like partly owned. And you have to schedule yourself like 6 months in advance to like reserve the facility. Like you have to reserve the facility. So you and your team of people go there for like 2 days or 3 days or whatever, run your experiments just to figure out the structure of a protein. And now, I mean, that's how they used to do it. That's how they still do it, but it's starting to completely lose out to another technique, which is called cryo-EM, where they're able to freeze proteins, essentially. And then the microscope itself is so powerful that it's an electron microscope. And again, I don't know like all the specifics of exactly how it works, but it freezes the protein to a point where then they can isolate it, and then they're able to get better images with that, or at least comparable images with a microscope, as they are with this massive facility that they spent, many, many, many millions of dollars on, which the
Available
microscope
soon on eBay for a little bit of $10.
Yeah. Right.
Buy it now for $25.
Yeah, exactly. The microscopes are still like insanely expensive, and not very many people have them, but it's crazy. Like, they show us pictures of like these proteins, and you're just like, wow. Like, you see this stuff in textbooks, that they've described it, kind of like what you were saying in physics, right? They've pre-described it of what it looks like. And then in structural biology, they just take images and they try and get as close as they can, create a model essentially, publish that model, and then other groups try and disprove that model by, oh no, it's our model, whatever it is, just by simple changes in the polypeptide in the actual protein structure. It's crazy. That's just mind-blowing to me. Like, you're talking about subcellular, but you're actually seeing the pictures. Like, you're seeing molecules. Like, how? That's crazy.
Directly with the microscope, or are they reconstructing the shape of the molecule from the, whatever information they get from that NMR technique, or from this cryo technique?
Yeah, I'm assuming they're rebuilding the structure itself. I don't want to like make any incredibly bold claims and say that they're getting the exact protein. I don't know, but still, it's just this like little fuzzy thing. It's like looking at a ultrasound of a baby. It's like this little like weird looking structure. And you're like, oh, it's little baby protein. And then you have to take an exam on it, and then you hate it. But I can understand like the idea of not being able to visualize it, but like at least with even down to molecular, like if you're talking about physiology, then you're talking about cell biology, then you're talking about molecular biology. Even in molecular biology, you can actually see, or at least get a visual of some of these proteins that's constructed out of something that supposedly they capture. So, that's probably something that you have to actually either believe or not believe. I don't know. But with physics, for me, whenever I hear that kind of stuff, I'm just like, I can't even begin to really visualize it. It's so hard. Like, I just believe it because I don't want to say that I believe it just because I was taught it, because that's the wrong way to think about it. But because of the model, essentially what we talked about earlier, they have created such a good model that if you do think about all these different models that fit into this bigger model of just physics itself, then you're forced to believe it, because everything fits that model, and it just continues to fit that model until maybe one day it doesn't.
Plus, those guys are really smart.
Yeah, well,
and they say it's right. So.
Yeah, yeah. Well, I don't ever want to walk down that path. But yeah, it's technically true. Yeah, some of those guys are insane. Just to think that there's a field out there that you can literally just think about it, and you've created something. Yeah. Like you don't necessarily have to have done anything, except use a mass amount of brain power, like Newton having the apple fall on his head. And I don't know what happened with Newton. Like, I don't know what he ended up doing, like how he ended up getting to the conclusions he did. But I don't know if there was any math involved. Maybe there was. But even pre-math, like, Aristotle and, well, I don't even know if that's pre-math, but just like, I guess, pre-complex math. Any mathematicians out there? I'm sorry. I really don't know anything about math. That's why I hate it. But it's difficult to wrap your head around something that people have literally just thought about it just by and of course integrated observations that they've made. And these observations have just gotten more and more complex over time as we keep figuring things out, and they seem to just continue to work. And then we keep discovering new things. And sometimes I wonder if we're really discovering things or if we're just making stuff up and it just works. It's like it just progresses our world, somehow. And then in that case, we're talking about a level of creativity that is unparalleled. You just could never find that. You're creating something out of thin air. And that's a really cool concept in its own right, I think, to be able to say that you've created something out of complete thin air.
Well, that's been happening for a long time. I mean, look at the periodic table of elements. What did the scientists who worked on that have to go on, really?
Mendeleev. I think that's right. I think he's the guy, right?
Well, he's not the only one to have worked on it, but I guess he's credited with pretty much the table that we work with today, yeah.
Yeah. Yeah.
But they didn't have any way to look at the structure of these atoms or these elements at the time, but still, just by thinking about it and observing, making the observations that they could make at that time, they were able to come up with something that, okay, we've got these atoms, these smallest possible particles that have these different characteristics, and these elements are made up of those atoms, and that was quite an intellectual feat, even though today every school child learns that and can understand it. Coming up with that the first time was amazing.
So let me ask you this then, like that, those kinds of discoveries and those kinds of attitudes, those kinds of thought processes, you might want to move your mic towards you more. Those kinds of thought processes, like if that happened in the last, 500 years? Something like that. Like the Renaissance, the Reformation, all that was within the last 500 years.
The periodic table was in the 19th century, I believe. I'm not sure when.
Yeah.
Early in the 19th century.
Yeah, I'm not either. But science essentially became science. At least modern day science became what it is now in the last 500 years. And we went from, I don't know how long we've been on this earth, but let's just say much, much longer than the 500 years of science. And up to that point, we were making incremental progress, no doubt about it, like in terms of just kind of growing intellectually, kind of curiosity, learning things. But we were learning things in kind of a haphazard way. It was more of just like alchemy, for example. It's just like, I'm thinking about this, right? But it's kind of just crap. It's not real. But it's an explanation. It's a model, right? Do you think that with this massive explosion in the last 500 years, which relative to the rest of time is just minute, it's a blink of an eye. It's like beginning to blink of an eye.
Mm-hmm.
Do you think that the discoveries, and you mentioned this, like kids right now are learning the periodic table, do you think that the discoveries we're making today are going to have that much of an impact going forward? Do you think like 200 years from now, we're going to look at quarks and, quarks and whatever else as just like, yeah, I mean, that's just common knowledge?
I don't know, to tell you the truth. I don't know if there would be any point to teaching the general population, physics to that level. couldn't say.
To me, it's a really intriguing thought in general, just to think of science, not just physics in general, but like just science. Like it blew up, and it made us so much more intelligent. And what's funny is that, like, while we're talking right in this moment, we could be complete idiots, you know? We genuinely could be. Like, we think we're smart, we think we're intelligent. We are, I guess, relative to the time that we are now. But I'm talking about humanity in general. I'm not talking about us. Although, you know, I'm not an idiot, but you know, still, if you ask me a math question, I am an idiot. But just like humanity, the amount of information that we know now, it's been an explosion. We've just grown into this just mass production, and just like being able to just predict things, and all these models are working together to the point where we're getting to this level of intelligence where we think we're, you know, maybe we're reaching the height of our intelligence, but in all reality, maybe we haven't even started, and science is just the first step. Like, maybe science is the Neolithic version of what is to come in thousands of years.
I wonder too, they say that we're only using, you know, X% of our true intellectual capacity. I wonder if those other 100 minus X%, if we'll learn to use that part of our intellectual capacity in the future. And if we do, I mean, you and I will seem pretty dumb to those people. But also, the other trend is artificial intelligence, and combining the memory and computing power and special kinds of problem-solving capabilities of computers with our brains, you know, with a mind-machine interface that people, maybe, I don't know what your time horizon was, 200 years? What are we going to be like in 200 years?
Yeah,
I mean, there seems to be no question that will be some kind of cyborgs that, or could be some kind of cyborgs that take advantage of the abilities that a computer has that humans may never have. And what is the world going to be like then? And my question is always, do we want that? Of course.
Yeah, I mean, yeah, of course, I think that's an interesting discussion too, when you're talking about like the morals of a situation, or if we ever want to put ourselves in a situation where there is a potential problem with cyborgs, artificial intelligence, whatever it is. But ultimately, I think we're always going to move forward. Like, no matter how many people, thousands, millions of people might say no to something, I think eventually it just gives way.
Seems that way too. Yeah.
Yeah, which you could look at it from like a negative standpoint, but I do think that I have a lot of faith in humans in terms of, and I'm talking about just from a straight biological standpoint. And you mentioned that we only use X amount of our brain at any particular time, or intellect, or whatever it is. I think back to actually a video that I released a few weeks ago talking about kind of how our evolution is quickening, how it's speeding up. And I do think that on a biological standard, I do think that humans have much, much, much greater abilities than what we present with now. And I think some of that evidence just comes from like lifespan, or if you look at people, like how tall we are compared to not just us, the two of us. You know, what are you, 5'11", 5'10"?
Makes you 6'1".
It's not, it's not just like there's just a lot of lines of evidence that we, with our better nutrition, with our better understanding, with better medicine, with better, like, all these different things, that, I mean, on the back end, a lot of these diseases are coming up that, we hadn't anticipated, but eventually we will overcome those as well, which is crazy to think about. But
You have more confidence than I do there.
I have supreme confidence in humanity. But it's just in the last, like, 100 years. In the last 100 years, think about that. Like, lifespan has increased, and I mean, dramatic. And even if you look at, like, 300 years, our lifespan has, like, doubled, or, like, increased by, like, 50%, something pretty remarkable. We've gotten taller, like, the average height has increased. Our health, I mean, I know we've got obesity and all that, and that's another issue to tackle sometime. But overall, I think the peak human now is much, much, much better off than the peak human 500 years ago. Or, and that's not just intellectually, but also physically. And I think that if we continue to adapt, I don't think that, like, whatever we produce, I think ultimately we will just always continue to move forward, and not just in terms of our technological feats, artificial intelligence, whatever it is, but also in our biological feats. I think people focus a lot too much on, like, obesity, for example, and that's no doubt an issue. And I think that maybe for the general population, that could be a problem, to the point where it does start to affect us and decrease some of the adaptations that we've made. But for those hundreds of thousands of people that don't suffer from obesity and don't suffer from some of these chronic illnesses, those people could move forward and really become something greater, even better, in humanity, which would be absolutely crazy. Like, moving into space travel and, like, all kinds of stuff. I mean, we're even talking about that now, space travel. That's really mind-blowing.
I wonder, though, I had this conversation with somebody recently about, are we really any smarter than the ancient Greeks were, for example, or the ancient Egyptians? Was the smartest person, 2,000 years ago or 3,000 years ago less smart or had less intellectual capacity than what an intelligent person today has? I'm not so sure about that. Well, our advantage now is that we have all this body of research that and learning that has taken place in those 3,000 years, and so we can start from elevated position. We don't have to reinvent all of that, and we have that to work with.
I can see that. I can see that argument for sure. I don't know, but you touched on my point already, that the body of research that we have, the amount of information that we can cram into our heads, gives us a mass advantage on those Greeks from back then.
It's available, but can we cram any more than we're already cramming into our heads?
But
we don't have to anymore, because we have this thing called the internet, and computers that store information and make it available to us quickly, that we can use to enhance ourselves already.
Yes. I mean, I for sure believe we can cram a lot more in our heads. We are selling ourselves so short. It's crazy. I don't think people are even trying, to be honest. I just have supreme confidence in people, if they have the intrinsic motivation to push themselves, then they can become an unbelievable version of themselves. So yeah, that's why I do think that there might end up being, and that could cause some serious problems, the distinction between some human beings and other human beings starting to have some of that segregation, which is kind of scary in a way, because I do think that would cause some issues, having people that push themselves, have that genetic profile. Their parents were people that really pushed themselves. Then on top of the genetic profile, their parents also pushed them, to be better, continuously within a supportive network, because it would have to be, right? It couldn't be just like negativity pushing people. But just having these really incredibly gifted individuals that work so hard at their different crafts and their intellect and all kinds of different areas. And if they continue to, assuming that they have kids and, it keeps going and going and going, then you have this like physical and intellectual specimen that's just really highly valued. And that could cause some serious issues because it kind of leaves the rest of society behind.
When did we ever highly value our really intelligent citizens?
You don't think so? Like,
No.
you look at like researchers and whatnot. Like, I mean, there may be some backlash here and there, but like I think for the most part, people really respect, doctors, lawyers. I mean, all those professions are professions that people really respect. I mean, we respect other professions for sure as well. Like, I think there's always going to be a balancing act. Like, as we're losing, as more people are going to college, this is a little bit on track, but as more people are going to college, we're starting to value more of like trade jobs, right? But I mean, I still think that, and those people can be really intelligent as well, just in their own craft, and especially if they have a passion for what they're doing. But I think, like researchers and doctors and lawyers, and I think those have always had a really high value in society. That's why people always try and strive for them.
I don't know, our society generally values people by how much money they make, and people who do research don't make a lot of money.
It depends. It depends who you work for. Obviously, university, most likely you're not going to be making a ton of money. You'll be okay, but you're not going to make like. But I mean, But if you go work for like a pharmaceutical company, you're going to be making a lot of money. If you are one of the scientists that actually produces ideas to how to improve things.
I'm not even sure about that. I mean, I'm sure they get paid well, but and if they get stock in the company, they'll probably make out really well. But those companies are set up to benefit the shareholders and not necessarily the people who work in the companies.
I don't know. Have you ever looked up the top 10 richest researchers?
No.
Oh man, some of them are making like, I don't know, in the millions for sure. I don't know, millions every year. Like it's pretty crazy. I mean, of course, they're all associated with different pharmaceutical companies or businesses that they've made, but all related to the sciences.
Well, if that's true, if you make your own business, then you're part of the shareholders, and you can get quite rich quite fast. But if you're just a hired chemist, you'll be making a comfortable living, but you're not going to get rich.
Yeah, okay. I mean, fair enough.
So I don't think that smart people are valued that highly in our society, and especially recently there seems to be an anti-intellectual bent to our politics, and people are actually, why should we listen to those climate scientists just because they all have PhDs and they've all studied this problem for their entire lifetime. I know better than they do.
Yeah, I think you're honing in on a vocal minority, though. I think the vast majority of people completely realize that, well, climate change is a real problem to varying degrees, of course. But yeah, I think so. They may. I don't think that we should confuse people who outright just reject it, just say no, it's not true, compared to people that are like, yeah, it's true, but we've got about 1,000 other problems we need to deal with. Like, I need my family taken care of before I can even begin to worry about that. And then you've got people that are like, this is the thing we need to worry about right now. So I think it's just a gradation. But I don't think that people are necessarily, at least the vast majority of people are not questioning researchers.
What I'm saying is that as a society, I would like to see us, when we're confronted with a question like, global warming, I would like to see us turn to the people who are best qualified to give us the best guidance going forward. And I mean, of course, some people want to do that, but it doesn't seem like we value the opinion of the people who are best placed to give the best recommendations.
Yeah, I still think that we still value those people considerably. Yeah, I don't really know what else to say on that.
Do you have any more questions on your list?
I do, honestly. I did have a lot of other things to talk about as well, but I think that this was a really good topic to start off the first podcast on. We can touch on the other ones.
I think it was. I think we covered just about everything already.
Yeah, we covered science. Yeah, so I think we can probably end it here. But hopefully you guys got some enjoyment, some entertainment out of it. It was fun for me. I certainly enjoyed it. It was a really interesting conversation. I think that's kind of the whole idea that I wanted to have with this, is that we, the two of us, tend to have some really interesting conversations, and sometimes most of the time we agree on things, but sometimes we have divergent thoughts, and it's cool to share that and just record some of that information because, yeah, I mean, I get that. Like, I tried this once, not in podcast format, but I tried to like video some of my friends, some of the conversations I have with my friends. Although it seems like every time we get together, we have these incredibly in-depth conversations about all kinds of different things. But every once in a while I have interesting conversations with my friends. So I was starting to video some of them. But, people just get, camera gets pulled out and people start changing. So I think with this kind of long form podcast style, I think what's nice about it is like, maybe the first 5 to 10 minutes kind of throw you off. But once you get into a rhythm of something you're really interested in and just letting your mind go without necessarily having a set path of exactly, this is all the things we need to cover, I think it's a lot of fun. It can be pretty exciting.
I think so too. And like you say, we're going to have this discussion one way or another, so we might as well have microphones in front of us, and in case somebody else unexpectedly wants to listen in, they can.
Yeah.
And, give us your feedback. I'd be glad to hear it.
Yeah, definitely. If anybody has any topics that they'd like, again, it's weird for me to say, to hear our opinions because, we're just two people. We're nothing special, but
except we're really smart.
Yeah. Relative to
stones and donkeys.
Exactly. I don't want to toot our own horns too much. But yeah, I mean, it's just fun to talk and just kind of see where the brain takes us, kind of. So anyways, we'll catch you next time. Hopefully in a month we'll record another podcast and discuss some more interesting, who knows, we have no idea what we're going to end up talking about, but we'll test another coffee. Maybe, hopefully we'll give a little more comprehensive review, because my review was good, but it's, somewhat better than some of the coffees that I can't remember names of. So hopefully it'll be better than that.
We'll get some good coffee.
Yeah, we'll get some good coffee. All right. Catch you next time.
Bye, everyone.